Have you ever wondered why the sun mysteriously disappears during a solar eclipse? This celestial phenomenon, as captivating as it is, has been a source of intrigue and mystery for millennia. In the distant past, our ancestors gazed up at the sky, their curiosity piqued by the sudden midday darkness. The Chinese, for instance, were recording eclipses as far back as 2000 BC. Their meticulous observations and calculations were part of an ancient tradition, one that saw the heavens as a cosmic blueprint of sorts, a guide that could help predict events and develop calendars. But it wasn't just the Chinese. Cultures around the world have been captivated by solar eclipses. Some saw them as portents of doom, others as divine messages, and still others as natural phenomena to be studied and understood. The role of eclipses in mythology and folklore is vast and varied. From the Vikings, who believed a monstrous wolf was swallowing the sun, to the ancient Greeks, who saw them as omens of disaster, eclipses have always held a special place in our collective imagination. Yet, as our understanding of the universe grew, so did our interpretations of these celestial events. The ancient fear and awe gradually gave way to scientific curiosity. The darkness was no longer an omen, but a galactic event in the vast expanse of space. But despite the many strides we've made in understanding solar eclipses, they continue to captivate us, to draw our eyes skyward with a sense of wonder and awe. Whether you're a seasoned astronomer or a casual stargazer, there's something undeniably magical about watching the moon slide between us and the sun, casting its shadow on our world. As fascinating as these ancient interpretations are, our understanding of solar eclipses has evolved significantly over the centuries. Today, we stand on the shoulders of giants, astronomers and scientists, who've dedicated their lives to unraveling the mysteries of the universe. As we delve into the science behind solar eclipses, we'll explore how far we've come and how much more there is to discover. The scientific journey of understanding solar eclipses began with the Greeks. As we examine the annals of history, we find Thales of Miletus, a Greek philosopher, who astoundingly predicted a solar eclipse in 585 BC. Thales, armed with the wisdom of the Babylonians and Egyptians, dared to move away from the fantastical explanations of astronomic phenomena and instead embraced a scientific outlook. This marked a pivotal moment in astronomy, setting the stage for a systematic study of the universe. As the centuries rolled on, the baton of knowledge was passed to the likes of Johannes Kepler and Edmund Halley. Kepler, with his laws of planetary motion, provided the mathematical framework to understand the dance of planetary bodies. His work laid the foundation for Newton's laws of motion and universal gravitation, forever changing how we perceive the universe. On the other hand, Edmund Halley, known for predicting the orbit of the comet that bears his name, also made significant contributions to eclipse science. Halley developed a method to predict solar eclipses by using the transit of Venus and Mercury across the sun. These advancements were instrumental in understanding the mechanics of eclipses and predicting their occurrence with increased precision. But what good is a prediction if one cannot observe? The development of telescopes opened a new window to the heavens. Galileo's refracting telescope, though primitive by today's standards, allowed humans to gaze upon the stars like never before. Over time, telescopes evolved, growing in power and precision. With these tools, astronomers could observe eclipses in greater detail, bringing us closer to the sun's secrets. From Galileo's humble instrument to today's high-tech solar observatories, telescopes have played a crucial role in deciphering the mysteries of solar eclipses. The mysteries of the ether began to unravel with the advent of modern science. With each eclipse, we deepen our understanding of our sun, the universal tapestry, and our place within it. The pioneers of eclipse science set us on a path of discovery, a path that continues to illuminate space. The total solar eclipse of April 8, 2024, is a spectacle to remember. It is a day when the moon's shadow dances its way across North America, casting a temporary twilight from Mexico, through the United States, and into the heart of Canada. The path of totality, the narrow corridor where the sun is completely obscured, carves a trajectory of darkness that millions are fortunate enough to witness. The anticipation leading up to this event has been palpable. It is as if the universe handed us front-row tickets to one of its most captivating performances. The air seems to hum with the collective breath of spectators, a mix of scientists, enthusiasts, and casual observers, all waiting for the moment. As the moon slides into place, the world around us dims, temperatures drop, and a hush will fall over the landscape. For a few precious minutes, the sun's corona, usually hidden in the glare of sunlight, is on full display. This ethereal halo of plasma, with its delicate wisps and arcs, paints a portrait of the sun's magnetic field against the backdrop of a darkened sky. But this eclipse is more than just a grand spectacle. It is a chance for scientists to study the sun's elusive corona in detail. The corona, despite being far from the sun's surface, is paradoxically much hotter. This solar mystery, known as the coronal heating problem, has puzzled scientists for decades. During the brief window of totality, researchers could gather valuable data, studying the corona's structure and dynamics, and perhaps inch closer to solving this enigma. Additionally, the eclipse provides an opportunity to observe other solar phenomena, such as solar flares and coronal mass ejections. These eruptions of high-energy particles from the sun's surface can interfere with our technology, and studying them during an eclipse can help us better understand and predict their impact. This eclipse is not just an otherworldly spectacle, but also a treasure trove of scientific opportunities. The fiery halo that encircles our star during a total solar eclipse is not just a beautiful phenomenon, but a paradox that defies the laws of physics as we know them. You see, the sun's corona is much hotter than its surface, a fact that seems counterintuitive. Imagine a fire that is cooler at its core and hotter at its edges. It's a conundrum that has perplexed astronomers since the late 19th century. The surface of the sun, or the photosphere, is a toasty 6,000 degrees Celsius, but step out into the corona and temperatures skyrocket to a blistering 1 to 3 million degrees. So what's causing this temperature inversion? Well, the answer is still shrouded in mystery, but ongoing research points towards the role of magnetic waves and reconnection events. These mechanisms are thought to transport energy from the sun's interior to its outer atmosphere, superheating the corona. But the corona isn't just a scientific enigma, it's also the birthplace of coronal mass ejections, or CMEs. These are huge bubbles of gas and magnetic fields that the sun occasionally hurls into space. When a CME collides with Earth, it can cause geomagnetic storms that disrupt our technology, from satellite communications to power grids. So how can we protect ourselves from these solar outbursts? This is where eclipses come into play. During a total solar eclipse, the moon perfectly blocks the sun's blinding light, allowing scientists to study the corona and CMEs in detail. These observations provide crucial data for developing early warning systems and mitigation strategies against space weather events. The sun's corona is a hotbed of scientific research, with many questions still to be answered. This celestial riddle continues to intrigue and challenge us, spurring us on in our quest to unravel the secrets of the universe. The future of eclipse science promises even more exciting discoveries. As we look ahead, we see a world where international collaboration plays a pivotal role in the advancement of eclipse research. In this global village of ours, scientists from different nations are coming together, sharing data and insights, and making coordinated observations from various locations around the world. This unity and diversity is pushing the boundaries of our understanding and helping us uncover new aspects of this celestial phenomenon. While the science of eclipses is fascinating, it's equally important to remember the impact of our actions on the planet. Eclipse tourism, the practice of traveling to witness an eclipse, has seen a surge in recent years. While it's a wonderful way to engage with science, it can also have negative repercussions on local communities and ecosystems. As we chase these celestial wonders, it's our responsibility to minimize environmental and cultural disruptions and ensure that our actions don't overshadow the beauty of the very phenomenon we've come to appreciate. As we delve deeper into the mechanics of eclipses, we're refining our prediction models. These improved models are not just about knowing when and where the next eclipse will occur. They are about optimizing observation strategies, about knowing the exact path of totality, about understanding how the moon's topography influences the duration and nature of an eclipse. These ongoing efforts are about precision, about getting the most out of every moment of totality. Our journey into the future of eclipse science is filled with promise and potential. As we continue to refine our tools, our models, our understanding, we keep uncovering new layers of this complex celestial dance. And as we do so, we're not just learning about the sun and the moon. We're learning about our place in the universe, about the fundamental laws that govern our existence. As we continue to unravel the mysteries of solar eclipses, who knows what fascinating discoveries await us in the future? If you enjoyed this video, be sure to like, comment, and subscribe for more content like this.
It's London Lee.